Hello there, beautiful day. What about having some burgers and while they are cooked, we talk about physics? Let's talk about Bohr radius. That's going to be our topic of our BBQ talk. Bohr radius. That number, A naught, equals 0.529 10 to the minus 10 meters. A weird number, and with that name, Bohr. Yes, the quantum physicist. That Bohr. But what is that number? Where does it come from? Probably from a horrible quantum mechanical calculation full of obscure formulas and probably with the Schrödinger equation in the center. But no, we're not going to do that. We're going to calculate A naught very quickly and very easily using dimensional analysis. And we will do it with a back of an envelope calculation, and we will use just four constants. So let's see how much can we do, how far we get. Why four constants? Well, the Bohr radius defines basically the radius of the hydrogen atom if it were a little ball. And what is the back of the envelope calculation? Well, it's finding a unique combination, if possible, of physical constants that ends up having units of length. But which constants? And why? Well, only those constants that really are essential for describing the physics that we want to describe. So, what constants are those? Well, the first is electrostatic force, because we want to imagine the atom like a little electron going around a little proton at the center, and of course that interaction is electrostatic, so it's given by Coulomb's formula, and Coulomb's formula incorporates 1/4 pi epsilon naught as a fundamental constant. We need, of course, the charge of the electron and the proton, which are equal multiplied, and the inertia of electron. The proton is irrelevant here because it weighs so much that it is practically at the center of the atom doing nothing. And the thing that is quantum here is that sets the quantum behavior is a constant h bar, which is basically Planck's constant. So here we see the units of each of those. And this is the actual back of the envelope calculation. But since my handwriting is so bad, I will show it very cleanly here. So what is the rationale of the calculation? Well, we say that the size of the atom is A naught, and it has to be determined only by the constants we have just discussed. And A naught must be expressed as a unique product of powers of those physical constants. So it should be something like that. The Coulomb's constant to some power called alpha, Planck's constant to some power called beta, the mass of electron to the power gamma, and the square of electron charge to power called delta. We substitute, of course, the units of all these. Remember that the way in which we write the dimension is m, big M for mass, Q for charge, and so on. So this is what we have just written. So we need the units of 1/4 pi epsilon naught, etc., etc. So this is all the units when we make the substitutions. So now we are going to do a 7th grade algebra. We're going to put together all the bases with their exponents and put them together and equal to length. So we have mass to the sum of the powers alpha, beta, and delta, and it must equal mass to 0 because to the right hand we just have length. Length to these two powers in here, to charge equaling charge to 0 power, and time equaling time to 0 power. So from here we can equate these powers to the powers to the right, and that makes a pretty nice system of equations. There they are. And then we can find that alpha equals -1, gamma equals -1 as well, and finally delta equals -1. So we can now reassemble the product of the constants and install the powers. This is what we get. For instance, h bar squared, the square root of a charge of electron to the -1, and so on. So this is what we get at the end. So apart from a dimensional constant that might appear here, we have found at least a form of the formula for the Bohr radius, and we may now look for the numbers to substitute in this formula to see how it goes. And again, we find a little 7th grade calculation. It's not a big deal, can be easily done. The pure numbers without the powers of 10, they go to 0.53 10 to the -1. The powers of 10, we put them together and we get 10 to the -9. So when we multiply this by this, we have 0.53 10 to the -10, which is the number we had at the beginning. And with the constants, we do the same. We take a little care to make sure nothing happens. At the end, they multiply it to get meters at the end. So this is the Bohr radius, calculated with no problem at all with elementary 7th grade math. Very nice. But now, is that all? Pure numbers? Doesn't think great fun. But here is the fun. It happens that Bohr calculated his radius in 1913. And in 2013, 100 years afterwards, a team of 9 scientists, most of them European, were able to devise a very sophisticated machine to do an experiment, and they end up with this beautiful image, which of course reminds us of what we see in our quantum physics books or chemistry books as being the cloud of probability of the presence of the electron around the proton. The proton cannot be seen in the image, and it's fantastic that this is experimental physics. So this is what we could call reality. So our numbers coming from theory, from ideas, from pure thinking, come up being something very concrete that we can see in an experiment. So thank you very much. Have yourself, have your burger, and see you next time.